Unit number 7, managing flexible storage with LVM. So here, what are the components of LVM? So how to recognize in your hard disk? So we created a partitions, that partitions, which are the partitions for LVM? So how to recognize that? So we already discussed in this managing file systems, that means in unit number 6. If you have the file system 8E partition ID, that is for LVM. Okay, we'll see there. And how to implement the LVM storage with the command line tools. So that means how to create the LVM by using the commands, and how to extend a logical volume with ext4 file system. So we want to extend the logical volume and we want to reducing the logical volume with ext4 file system, and extending and reducing the volume group. So volume group is there. So for that volume group, if you want extend, if you want we can decrease. So how to do that, and how to create a snapshot to facilitate a data backup. So whatever the data will be there, we can take a backup. So how to create a snapshot. These are the topics in this unit number 7. So we are going to discussing now. So in this next slide, here 3 hard disk will be there, 1, 2, 3. In the second line, same hard disk will be there. See here, these are individual hard disk. This is the individual, this one is individual, this one. But in the third line, these 3 hard disks will be combined together. And fourth one, 2 hard disk is there. One is for unused space, and another one is for using space. So just I press enter over here. So partition physical storage, that means we are created a physically storage, that is for LVM. So that physical storages we created as a physical volume. Then these are club, so we can create the all these PVs, we can create as a 1 VG, nothing but one volume group. From this volume group we can create as a logical volumes. So how to create that logical volumes, we will see. And I have one more scenario in this logical volume manager we created. See here, same kind of thing. This is a SCSI hard disk. Under that hard disk I have a one hard disk, that is /dev/sda, and one more hard disk is sdb, and one more hard disk is sdc, and one more is sdd. So using this hard disk I can create a one physical volume. So this is 100 MB, this is 100 MB, this is 100 MB, this one is 100 MB. That means 400 MB hard disk will be there. From this hard disk I created as a /dev/sda physical volume. That volume is added to the volume group. And one more HDB is there. This one I created as a physical volume /dev/sdb added to the volume group. So one more hard disk I have, that is /dev/sdc. That one I created as physical volume, that I have added to the volume group. So first I used 3 hard disks. One is SDA, SDB and SDC. So all this I created physical volume, that I added to the volume group. From this volume group I can create the n number of logical volumes. In your SCSI hard disk we can create 3 primary partitions. Fourth one is extended. Under that we can create the up to 14 logical partitions. But here we can create the n number of logical partitions. Now see, this is I already told you 100 MB, 100 MB, 100 MB. That means a combination of these 300 MB gives a volume group is 300 MB. Using that 300 MB I can create as the logical volumes. Now one of the logical volume has to be extended. That means if you first I created here 150 MB, remaining rest of the space I allocated for here. Now this 150 MB I want to increase into the somehow 50 MB, that means 200 MB I want to increase. So for that I don't have the hard disk. So in online I can add to the one more hard disk, that is /dev/sdt without the space of 100 MB, create as a physical volume, then add to the volume group, existing volume group, otherwise you can add to the new volume group. I am adding to the existing volume group. So from this I can extend this logical volume whenever it is required. If I don't want, decrease it, I can reduce this volume group also. Okay, you got this scenario of this one. Okay, now Now we'll move into this one, server. In this already some partitions is created, so 7 partitions is created, because here I can't maintain the n number of hard disks, right? Using this hard disk I can create the 3 partitions of 100 MBs. Using the partitions I can treat it as a hard disk. For that I can get the logical volumes. We'll see how. fdisk space /dev/vda p for partition table is already 7 partitions is created. I want to create a new partition, so for that option is n. Default it is taking 100 MB, 100 MB. I want to use this partition for LVM, so for that I have to change the partition ID. So for that T for to change the partition ID. Which partition? 8th partition. Already existing. If you don't know the codes, you can press capital L. We can get here 8E is for Linux LVM. So now you can directly give here 8E. Now the partition system type of partition 8 is to be 80, so you can check P here. Earlier it is Linux, now it is LVM, Linux LVM. Same kind of thing. 2 more partitions I can create. 100 MB and 1 more partition. 200 MB. Space is not there for me. From DMB. So 2 partitions, VDA9 and VDA10. So for that I want to change the partition ID. So 9 8E for 10 8E T for partition. Now W write changes to disk. Now as usual reboot. Now my machine is rebooted. The server is putting up. Server is booting up. Now login as user. Password is Red Hat. fdisk space /dev/vda p for LVM is created. Now quit. So as per our scenario, these raw devices I have to initialize into the physical volume. So for that pv create, at a time we can give the 2 partitions /dev/vda 7 8 /dev/vda 9. From these 2 partitions I created the physical volume. See, physical volume /dev/vda 8 successfully created. Physical volume /dev/vda 9 successfully created. Now volume group, vg create volume group name. I am giving the volume group name is vg12. Okay, so from which these are the physical volumes /dev/vda 8 /dev/vda 9. Volume group is created. So from this volume group is created. Now I want to check whether how much of space is allocated for that. And one more here, how many physical volumes we can add to one volume group. From that volume group, how many logical volumes we can create. Okay, This is the one of your intro question. You can check. So before I will tell you, before that we can check here VGS. So VGS for volume group, it will display shows volume group shows, it will display. So VG12 is a volume group. How many physical volumes we are added to this volume group? That is for 2. From this, do you created any logical volumes? No. Do you taken any snapshot? No. Attribute size, volume group size, free space. Same thing here, one more volume group is there for us, that is VGS survey. From that, for that one physical volume is created, 3 logical volumes is created, so it is having the size over here. Okay, same thing we can check here VG display. If you given VG display, what means what are the volume groups? See, volume group VGS survey, VG12 is, it will display. Particularly means VG display VG12, so we can get VG12. So here, what are the access for this volume group? Read write. Can you resizable or not? The status is resizable. Max LVMs we can create. Current LVM, max physical volumes. Current physical volumes is 2. Actually 2 only is there. What is the volume group size? 192 MB. What is the physical extent size? PE size is physical extent size. That means by default 1 extent equal to 4 MB. 1 extent equal to 4 MB. So here we almost we have the total PX physical extent is 48. 48 into multiplies with 4, 192. So we are not created any LVMs. For that allocation physical extent size is 0. These are 48 physical extents are free. Okay. Same thing you can check PVS. For this /dev/ VDA2, that is VGS service to created, VDA8 and VDA9 volume group 12 is to added over there. Okay. PV display also we can give /dev/ VDA8. So its size is 100 MB, still not useful in that last plus found directory like that. It will create it. It is allocatable. Yeah, we can allocatable. Size is 1 extent equal to 4 MB. Like that it will be created. Now I want to create logical volume. LV create space -n for name. I am giving the name is LV1 hyphen capital L. Size, I want to create the logical volume is 150 MB capital M. From which volume group? 1, 2. It's created. Now if you check volume group LV display /dev/ VG12, where it is there? LV1. So volume logical volume name, from which volume group? Read write, status is available, size 150, right? Approximately we got it 152 MB. Now if you check VG display VG12, see now current physical volumes 2, volume group size is 192, 4, total is 48. Under that allocatable is 38. So still we have the 10, so that means 40. Same you can check VGS. One logical volume is created. Still we didn't create any snapshot. Logical volume. Okay. Now we created the logical volume. So this logical volume we want to use for file system. So make file system mkfs space -t ext4 /dev/ VG12 /LV1 formatted. Now I can create a directory mkdir/store. Here I want to mount it. Mount space /dev/ VG12 LV1 under the directory store. So it's mounted. df space -h is mounted. I want to this partition, this LVM in the permanently after rebooting also. For that I have to provide the entries under /etc/fs tab /dev/vda vg12/lv1. This is the device name where we are mounted /store file system ext4 defaults 0 0 save and exit. It is available under after persistently, nothing but reboot. This is to create the logical volumes. Now we created the logical volume, so just we can store whatever the data you want. cd/store, so you can touch 1 2 3 files, you can store it. After that you can come out from there. This is the logical volume. Now I want to increase my extended volume, so nothing but lv display /dev/ in vg12. So this is 152 MB. I want to increase my logical volume into the 170 MB. So that means 20 MB I want to increase. One extent equal to 4 MB. That means how many extents we can use? 5 into 4, 20 MB. So we can extend. We'll see how to extend. The command to extend is lv extend. Before to extend, first of all, that much of extents, that much of space is there or not in your volume group, we have to check. So for that, vg display vg12, check here 192 38 is already allocated, still 40 MB. That means 10 extents is there. Our requirement is 20 MB. That means 5 extents. Okay, now we can increase lv extend space hyphen small l 5 /dev/ vg12 lv1. Sorry. So 152 MB optional plus. While increasing your logical volume, you have to give the add symbol. While decreasing, we have to give the minus symbol. So lv extend space hyphen l plus 5 /dev/vg12 lv. So now it is extended. So it should be resized. We have to give the command resize to fs space hyphen p /dev/ vg12 /lv1. It's resized. So that means whatever the mounted file system will be there, all the files will comes to one place. It's a nothing but defragmentation. Okay, now it's happened. This is the command for extending. Now I want to reduce. For extending the logical volume, no need to unmount your file system, but for reducing the logical volume, we need to unmount the file system, because we can lose the data. So you mount /dev/vda where we are mounted, store, it's unmounted, check over here, it's not there. Then now e to fsck space hyphen capital F // VG12 /LV1 external file system check. That means it will check the what are the inodes and blocks, how much of size we are given, what is the directory structure, how the directories are connectivity, whether you given any hard link or soft link, what is the reference counts, everything it will check. Now we can give the resize to fs -p /dev /vg12 /lv1 with we can give the 96 m. So that means I can decrease 96 m. So I am giving a command, this one, resize to fs space -p /dev /vg12 /lv1 space 96 m. So that means it will ready for reducing the LVM up to 96 MB. This command will give a meaning is the LVM is ready to reduce up to 96 MB. It's resize. Now LV reduce -L -6 extends /dev /vg12 /lv1. While reducing your activated local logical volume, you may lose the data. Yes, earlier 172, now it is 148. So now you can mount it. Mount space -t, directly you can give /dev /vg12 /lv1 /store space -h. This is how to decrease and how to increase the logical volume. Now we will discuss about the how to extend the volume group and how to extend the reduce the volume group. So volume group. So I don't have space over here. Just think VG display VG12. I have only 11 extents. If you don't have the space over here, so now we want to increase your volume group. So how? So before that, in my hard disk, what are the partitions is available? I have to check. So in this already one more partition is available for me, 120 MB. So this partition I can use for logical volume. pv create /dev /vda. What is the partition number? 10. Okay. Physical volume VD10 is created. VG create. If you are use the VG create, it will create one more volume group. Okay, that means VG create volume group / volume group name is VG123 from /dev /vda 10. Volume group is created. So just you can check VG display, we can get VG123. Here one extent equal to 4 MB, but one extent equal to 8 MB if you want to require. Otherwise client is required. Don't create one extent equal to 4 MB. Can you create one extent equal to 4 MB? Based on that, extent size will be decreases. Okay, then after that time, first I am going to remove VG remove /dev /vda 10 from VG123. Okay, it's removed. Now VG create space hyphen s, size is one extend equal to 8 MB slash dev slash vg 1 to VDA 10. For the volume group, VG 123 is created. You can check VG display, VG 123. Okay. This is with one extra. How to give the create the volume group with the extents. See, one extent equal to 8 MB now. Again, I am removing VG 123 slash dev slash VG 1 2 slash LV1. Okay, it's removed volume group. Now I want to extend VG extend. See, 1 second. VG remove VG 123 slash dev slash VDA 10. Okay, so we deleted already. VG extend VG 12. Okay, VG extend VG 12 slash dev slash VDA 10. Earlier it is 192 something MB, right? See, 192 MB. Now we increased. So VG display VG 12 308 MB. So VG reduce means VG volume group reduce. VG reduce VG 12 from slash dev slash VDA 10. Now you can check 192 MB. Okay, this is how to increase your logical volume and how to decrease your logical volume, how to extend your volume group and how to reduce your volume group. Now how to take the snapshot. So that means how to use this LV snapshot. What is the use of LV snapshot feature? LV snapshot is a volume. That means it's a special type of volume. It presents all the data in that volume at the time of snapshot was created. So that means if I have the space right now, so for that if I created a snapshot for that LVM, so whatever the space is there, whatever the data will be there, it will take as a backup. So whenever you want, you can restore it. So like that LV snapshot we can use. So for that, how to create the LV snapshot? LV create space hyphen s to create the size of that one, snapshot hyphen n. That means I am giving the snap, just I am giving the snapshot name of LV snapshot hyphen L. I want to create. If I don't have space, I can give the 50 MB. From volume group to which logical volume slash dev slash VG12 slash LV1. I think that LV is not there. Yes, LV1 is there. lv create -s -n for snapshot from this logical value. I am giving lv create space -s for snap -n snap name, this one. So now it is created. This snapshot we can create format ext4 /dev/ vg12 /snap. Sorry. Insufficient space. Oh, it's not created order. Snap is created. Now mkfs, if you want to check lv display /dev/ vg12 snap 32 MB is created. Okay, now mkfs space -t ext4 /dev/ vg12 snap formatted. mkdir create a directory snapshot and then mount it, mount /dev/ vg12 lv1 /snapshot. Okay, now mkf df space -h, it's mounted. So we have to give the fs tab win /vpc /fs tab. So give an enter here /dev/ vg12 snap. We created snap shot file system ext4 defaults 00. Save and exit. Okay, by default it will be stored over there. Like this snapshot we can create, we can take up the backup. So I will show you in the graphically the same thing. System administration, logical volume management. Click on this. VG12, go to the logical volume, LV1 whichever we created. Snap is the snapshot. So this is the, still we have this much of unused space will be there. For this is a logical volume, snap is a snapshot. Okay, this is your volume group. So what is the commands we used for here? Just I will give you a brief on this. So first I created the partition in 504. After that I created the physical volume. Then after that I created the volume group. Then I created the logical volume. After that I formatted the file system. And I mount it over there. Mount in FS tab is 521 in FS tab in persistently LV display resize to FS to extend the logical volume, and after that I try to create the snapshot. Okay, we discussed everything over here. So now in unit number 7, how to recognize fdisk space -l in that partition id 8e will be there, Linux LVM storage will be there. How to implement using command line tools. So first we have to create the raw device. That raw device can initialize as a physical volume. Physical volume we can add to a volume group. From that volume group we can create as a logical volume. So we can add to the existing volume group, otherwise we can add to the new volume group. And logical volume, from that volume group we can get the number of logical volumes. Okay, and extended a logical volume. Whenever we want we can extend the logical volume, whenever we want we can reduce the logical volume. Whenever we want we can extend and we can reduce. We can take the snapshot. We have the limitations, we know, right? So we can create one extent equal to 8 MB, that is the default. Up to we can create the 1024 MB. And one more is we can create physical volumes, that is 256 physical volumes we can add to the one volume group. From that volume group we can create the 256 logical volumes. Okay, this is this unit 7. So now we'll move into the unit 8.